Hey YouTube, welcome back. In today's video, we will tackle a huge interview maker or breaker, which is designing for failure. No matter how shiny your architecture looks on the whiteboard, interviewers want to know what happens when things go wrong, because they will go wrong. So let's start with the first, why reliability matters. Reliability matters in three things. First, user trust, because the user trust will plummet after a single bad outage. So because of that, you need reliability. Number two, a downtime equals lost revenue, lost data, and a bad PR. And three, which is a goal, minimize the blast radius, recover fast, and reverse the user experience. All of these things will I guess can convince anyone that reliability really matters in handling in facing failures and handling the system availability and the scalability. So the first thing that we'll talk about when it comes to reliability is the data replication across regions, because we focus right now on data reliability. So we have multiple things that we need to talk about when it comes to data replication across regions. First, we have synchronous replication. Synchronous replication for strong consistency, good for financial ledgers, higher latency, I guess. Next, we have asynchronous replication. It's for global read performance, eventual consistency, but quite quicker reads. And lastly, we have the Quorum or the Paxos Raft clusters. It's our clusters to survive nodes loss without a split brain. There is something called a PRO, which is a recovery point object, and RTO, which is recovery time object, to show you speak reliability. These two things, I would say, if you use them in your system design interview, you might be succeeded. Next, we have want to talk about failover strategies. So we have four things. First, we will talk about active passive, which hot standby takes traffic on takes traffic only on failure. And the second one, we have active. Basically, both regions save traffic, health checks route around failure automatically. Number three, we have circuit breaker and retries. This stop cascading outages, apply exponential back off. Number four, we have chaos testing. It injects failures to validate your playbook. Next, we want to talk about graceful degradation. Basically, graceful degradation serve a static fallback page if personalization fail. It queue writes locally and show cached reads if the DB is flaky. It turn off non-essential features to keep checkout or messaging alive. We can talk about real world example. Let's talk about like a payment system. So let's say that we have a failed transaction path. So we detect failure via timeout or negative ACKs. We will make an important retry with unique transaction ID, and cap the retry count. Also, if the retry fails, we roll back a provisionally ledger entry and log to the DLQ, which is a dead letter queue. Number four, an asynchronous job will sweep the DLC or the dead letter queue, notifies the user, and alerts the developers. So in conclusion, designing for failure shows maturity. You are not just building a system that works, but system that keeps working when the unexpected hits. Remember, replicate, fail over, degrade gracefully, and always have a recovery plan. So yeah, that's it for this video, and see you in the future.